Hi, I'm Mihai John, and I want to share some of my work experience with my fellow colleagues around the world. Electrical circuits can get faulty, and that's pretty annoying. Imagine you come from work and then you lose the light in your room, or maybe you lose in your garage the ring circuit, or maybe an RCD will trip and then you lose the power for your entire home. I want to talk in this video about the design, the mistakes, and what would be the easiest way to identify and rectify this kind of faults. As you know, when you look to the distribution board, what type of faults you can have. An RCD can trip if you have an earth leak, or a circuit breaker can trip if you will have an overloaded circuit or a short circuit. So let's see how this is gonna be.
Using only one RCD, residual current device, to protect all circuits in a home electrical installation, even if it provides the appropriate protection, can lead to problems when earth leakage faults occur. This is because if the RCD trips, all circuits in the home will be affected, causing inconvenience and potentially affecting essential systems such as lighting and power. To address this, it is recommended to install separate RCDs for different circuits to minimize the impact of earth leakage fault and provide more targeted protection. Using only one RCD to protect the entire electrical circuit of your home, it is convenient and cheap. But let's see what happens if the circuits will develop an electrical fault. If you'll go for the cheaper version, you will have an RCD, and then the RCD will provide life to the bus bar, and then you have to install circuit breaker for every single circuit. But remember, all these circuit breakers will receive power from one common RCD, and the RCD will look to the sum of the earth leaks you have into your home. If you have only one RCD, you'll observe this. You turn on the RCD, and then the RCD will provide power to the entire bus bar, and then one by one you will turn on the circuit breakers. Then all your circuit will be live. If an electrician will be good, he will mark every circuit. Believe me or not, I found unmarked circuits. A normal customer is not aware of the problem having only one RCD. As long as the system works, he'll be okay. But look in this scenario. The system developed a tiny earth leak, and this earth leak will create a lot of issues. If you look now to the ground floor lighting, the arrow, it is orange, and on the earth bus bar you will see an orange arrow, which tells you you have an earth leak. In this case, the RCD will trip, and then you have to call an electrician to find the fault. So now let's see how can we identify the faulty circuit in an easy way. You'll observe now that your electrical system developed an earth leak. There's an earth leak between the ground floor lighting circuit and the earth. RCD trips if the earth leak exceeds 30 milliamps, providing electrical safety and reducing the fire risk. So we have this electrical fault, then the RCD will trip, interrupting the entire circuit. What you'll see here, the entire home, it is in a darkness, and you don't have even power at the sockets. That means the RCD tripped, and you lost the entire power supply. If an RCD trips due to an earth leakage fault, it will interrupt the entire electrical power supply to the circuits it protects. This means that the entire home will lose power, as the RCD is designed to disconnect the electrical supply in case of a potentially hazardous situation such as an earth leak. However, having multiple RCDs installed in different areas of the building can help to minimize the impact of the fault in one area. Or you can use RCBOs to protect each circuit individually. In this case, if your home will have a faulty circuit, or you have a faulty appliance which will generate an earth leak, only that circuit
will be tripped, and then the rest of your home will have a power supply. In case of an earth leak occurring between one circuit and the CPC, we can identify the faulty circuit by following these steps. Turn off all circuit breakers, reinstate the RCD, reinstate one circuit breaker at a time. When the RCD trips after reinstating a circuit breaker, it indicates the faulty circuit causing the earth leak. Identifying the faulty circuit and isolating it by turning off the related circuit breaker, it is an important step in electrical troubleshooting. Securing the circuit breaker with a lock can prevent accidental or unauthorized activation, ensuring the safety of the circuit. By keeping the faulty circuit isolated, you can safely reinstate the power to the rest of your home while fixing the problem with the ground floor lighting circuit. Failing to secure a faulty circuit breaker can lead to accidental or intentional activation, which can result in the faulty circuit tripping the RCD, causing the loss of power to the entire home. So technically speaking, if you will activate the circuit breaker of the faulty circuit, the RCD will trip and the entire home will be without power. Now I want you to look to this scenario. Let's say we have a short circuit between neutral and earth. What happened in this situation? The RCD will trip. And obviously you're going to turn off all the circuit breaker and then you will reactivate the RCD. The problem is that any circuit breaker you try to reinstate, it will trip the RCD because you cannot isolate the fault. The fault happening between neutral and earth. It is very important to disconnect all appliances and turn off the power source before checking for electrical faults in a circuit. This helps to ensure safety and eliminate the possibility of the false reading caused by the faulty appliances. After isolating the circuit and unplugging all the appliances belonging to that circuit, you will use the appropriate tool to check the resistance between neutral and earth. If you will find out that the resistance is too low, then one by one you will disconnect the neutral to see what circuit it is faulty. And look, we're just lucky. In our case, the first neutral to disconnect tells us that we have a fault. In the old homes, the distribution boards are nothing but a mess. So you look to the wires, you don't know which wires which. It's very hard sometimes to pair them. So after you will realize that you have a very small resistance between the neutrally disconnected and the earth, you'll also disconnect the earth, and once you disconnect the earth, you'll realize you have an open circuit. So you're lucky again, you catch the first wire. Now you will check the resistance between the wire you disconnect. They should be paired probably. And you will realize that you have a lower resistance, a resistance that will be equivalent with a higher value than 30 milliamps. So that's enough for RCD to trip anytime you will enable a circuit breaker. After you disconnect the faulty circuit, you will measure in between neutral and earth bus bar, and then you also disconnect the live circuit. Then you will prepare to reinstate the rest of the circuits, and later on you can start working onto this faulty circuit. Having the faulty circuit breaker secured, you can enable the main switch, allowing the power to reach the RCD. And then you can also enable the RCD, allowing the power to reach the bus bar, which brings power to all the circuit breaker. Now your circuit breaker, it is safe, no one can activate it. And then you can activate the rest of the circuit breakers, and the exception of the faulty circuit, all the circuits in the home will have power. In this scenario, we have an earth leak from the face to the ground. If the resistance is very high but the amps are over 30 milliamps, the RCD is obviously triggered. In this condition, we have a severe short circuit between live and earth. This short circuit can trigger the circuit breaker as well as the RCD. Now, a short circuit between live and neutral will trigger the circuit breaker, and because of this electrical shock, sometime the RCD will be triggered as well. For a convenience, you can use RCBOs. While a residual current device is designed to monitor the residual current in a circuit and disconnect the supply if an imbalance is detected which can indicate a potential fault, an RCBO, it is a residual current circuit breaker with overload protection. It's a combination device that provides both RCD and MCB, miniature circuit breaker, protection in one unit. It monitors the residual current and also provides protection against overloading and short circuit in a specific circuit. If a fault occurs, only that circuit will be disconnected, allowing other circuits to continue functioning normally. This is great because can you imagine you just watching TV or doing something important, if one circuit inside your home will be faulty, then only that circuit will be stopped, not the entire power supply to your home. Now let's zoom a little bit deeper into this ring circuit. Imagine you come from work and your RCD trip, you have an earth leak, and then you will do the basic investigation, go straight to the distribution boards, turn off all the circuit breakers and turn on the RCD, and one by one reinstate the circuit breaker. Then you will find the faulty circuit. I suggest that you will unplug all the appliances from the faulty circuit if you find the ring circuit, kitchen, whatever it is, and then you will enable again the circuit breaker, and then you will see if the circuit is okay, it means one of your appliances is broken. If the circuit will treat the RCD again, then you have to take one step further and you start investigating the ring circuit to find out what damage might be inside the wall or burned sockets, whatever it could be. You can have many surprises. While it's true that the end goal of electrical work is to ensure that electricity is flowing to the lights and sockets, it is important to note that neglecting all bad jobs can lead to serious safety hazards such as electrical fires or shocks. So now let's start with a good circuit. We have a good circuit, only one spur, it's a ring circuit. Faults can occur anywhere, in the beginning of the circuit, maybe in the middle of the circuit, or maybe in the end of the circuit. It's up to how you have to look to the problem, clockwise, anti-clockwise. So what can I do in this case? I cannot have a radiography to the wall. Well, I show you the schematic is just an example, and if you're lucky enough to find some paperwork, but I didn't really have this privilege just working in London. So you remove the lead of the distribution board, and then you remove the wires after you turn off the isolating switch. And that you will see. You will see both terminals of a ring circuit. Then you have to go to the middle of the circuit and to pull out a socket, because I want to split these circuits in two to see which side is faulty. And to do that, I'm going to the middle of the circuit, I'm pulling a socket out, and then I have two wires. I have, let's say, the north and the south. and I check individually both. See, if you will have a radiograph, you will know which side is broken, but you don't. So how can I do this? Because I don't know. I see this section is broken, but I don't know where. I can see that if the, like, you know, through the wall you cannot see. When you do the measurements, you break, you pull out another socket and you break the circuit. You see on the top left hand side, and then you realize that the circuit is broken between the last socket and the distribution board. So you will just make that part redundant for a while. If you cannot repair, you might have to break the walls, and then you will put the socket back, reconnect the circuits, but then you have a problem. You have 32 amps for a circuit is not ring anymore because you broke the ring. So you isolate that part which is faulty until you repair it. Then obviously you have to turn off the power supply, and then you have to downgrade this circuit. You have 2.5 cables, an example, not ring circuit. You will have to apply the derated factor. You will just change the circuit breaker, and you will put a 16 amp circuit breaker, and you'll tell the customer you don't have the same power like before because part of your circuit is broken, and in that case you have to come back to break the wall, to change the wire, whatever. If you leave the circuits running, obviously the customer knows he cannot use heavy duty stuff like microwaves combined with washing machine, fridges, toasters, etc. So this is it about the ring circuit and the rest. Thank you so much watching this video, guys, and I will see you in my next video. Again, I want to remind you I'm doing this for free. Helps me to improve my English, and I want to share with my fellow colleagues everything I experience on the field on a daily basis. Thank you very much, and see you.